Evangelista, and today we're going to be continuing our lecture on organic chemistry, part of the IB Chem SL curriculum. Today we're going to be talking about alkenes. These are carbon and hydrogens that have a carbon-carbon double bond somewhere. Now, as we go through these reactions, you do not need to know the mechanism on how they happen, but it's always good to kind of consider how the electrons might be moving to allow these reactions to happen. So for the first part, we're going to go from an alkene, something with a double bond, to an alkane, all single bonds, through hydrogenation. So we can add hydrogen to this alkene and make it an alkane. To make this happen, we do need a nickel catalyst, and we need to add in some heat, so 150 degrees Celsius. And when we add hydrogen, we can see that it hydrogenates both carbons of the double bond. We can do the same thing with bromine. So we can go from an alkene to a dihaloalkane through halogenation. Now notice that halogenation in alkanes required UV light as a catalyst. We do not need a catalyst for alkenes. This reaction will happen on its own. So we can see we've added 2 bromines on both of the carbons of that double bond. We can turn alkenes into alcohols through hydration. And so for this we will need concentrated sulfuric acid and also some heat. What this will do is it will add a hydrogen to one of the carbons and add a hydroxyl group, an OH, an alcohol group, to the other carbon. We can also go from an alkene to a haloalkane through halogenation through HCl. So we can see the carbon-carbon double bond will be, one of them will receive the hydrogens and one of them will receive the chlorines. Now, just on a side note, it's actually important which carbon gets the hydrogen and which carbon gets the chlorine. You guys won't need to worry about that too much, the stereochemistry of what is going on, but just, like I said before, be cognizant of maybe how these reactions actually happen. How do the electrons move around for these mechanisms to happen? And it's also important to think about what are the different ways that these atoms could be added to that double bond. Alkenes can be polymerized. So polymerization, a polymer is a long chain of repeating monomers. And so here we have ethene, and the repeating unit of ethene is actually C2H4. And here we have propene, and so the repeating unit of propene is C2H, what is that, 6, C3H6 right there. Pretty much the difference between this and this, the repeating unit has a single bond between the carbons, while the actual polymer, represented N right here, meaning this can repeat multiple times, has a double bond. Same thing if we look at the propene here, it's got the double bond there, while the repeating unit does not have the double bond. And so here are just a chart that shows the summarization of the reactions that we went over. We can add polymers, that's polymerization. We can make it into an alkane through adding hydrogen in a nickel catalyst and heat. We can add bromines to the double bond. We can add HCl, and we can also make it into an alcohol by adding concentrated sulfuric acid and heat. Remember, we were talking about you need to know the colors of the halogens. Remember that when you add the bromine in this, when you add the bromine, it's going to go from brown to colorless. Also, one of the ways that you can tell the difference between an alkane and an alkene is mix it with bromine. And remember, an alkane requires UV light, so and an alkene doesn't. So the one that turns from brown to colorless without the addition of UV light is going to be the alkene, while the one that does not turn unless it has UV light is going to be the alkane.